Hey everybody, today I'm going to show you in this video, I've got a brand new NOCO charger that I installed, and if you look at a previous video I put out, I'll show you the charger and how I got it all plugged in. But today, this is the data from the first charge event. The batteries are probably halfway depleted, and for refresher, this is about trolling motor batteries. I have two 100 amp hour 12 volt batteries, Battleborn batteries. They make a 100 amp hour 24 volt pair that I use for my motor guide trolling motor. It's in my chaparral that came factory with a ProMariner 20 amp triple bank charger. That's a good charger, but it's intended for lead acid batteries and it's not optimized for lithium ion. So I've switched to a NOCO GenPro charger. As I showed in a previous video, I'm installing it and setting it up. So now you'll see just a little bit of how I set up to get going with the generator and the collecting data. And then the rest of this video I'm going to go through the analysis and I'll show you the charge curve for the NOCO, the charge curve again for the ProMariner, how they compare, and how that, some things that I found and learned about the NOCO charger that were surprised me just a little bit, but turned out to be very good. So here goes. All right, I'm ready to test my NOCO charger and see how it works. I'm going to record data as it charges, and we'll see how the charge profile is. Because I'm away from home, away from the house, I'm going to use a small generator that I have here to power the system. So I'm going to fire it up, fire up my computer, plug in the charge. I have my laptop set up for meter view so we can monitor the voltage as the thing charges. And the system is at 13.16 officially, and my meter runs off a little bit. It's showing 13.09. That's kind of the standard offset using my Radio Shack data logging meter. The meter view says I'm at 13.16, so she's fired off and is beginning to charge. The voltage is at 13.28, and actually on the bottom it says 26.56, so 28, 28, 56, so the pair is running double what the single one is, so that's good. I'm only about a half hour, 45 minutes in, but we're up to 13 and a quarter on there, 13.36 off the monitor. And there's my charger showing one above 75% and one less than 75%, with the voltages about equal at 13.53. Well, it looks like it's finished. I'm sitting at 14.4 on one battery, 14.39, and then 28.79 for the whole thing, which was double. And it's putting about an amp and a half in it right now. It was running 0 a minute ago. Up in the upper right, it's got kind of a sawtooth where it looks like it's putting in a little current and then quitting, putting in a little current and then quitting. So I would say we're finished. The charger's got the lights kind of pulsing a little bit, just barely, like it's just about there. I was at 14.6 with that amp and a half, so it's going to 14.6 and then taking power off. And then it's going to 6, and repeating. I think we've hit the point. All right, the charging's done with the new NOCO charger, and I'm going to walk you through some of the data. It's a lot nicer to do this when I don't have the generator buzzing away in the background and making noise. So I'm going to show you a few things here. I've crunched the data into some slides, and first off, is to take a look at I'll call it's a Battleborn ProMariner. It's my original charge curve, and it's with the batteries from a pretty well down. They're probably down they were probably down to about 30 or 40% state of charge. I've never had them to the bottom, but they were down a ways. And this is just a good example of how they fire up and how the charger brings voltage up, comes across, brings it up to the top, ends up at 14.6, and then I cut it off and let that naturally decay and settle out. Then I've got a second curve here, and the reason I gave you the first one is that this one's got a couple of anomalies in it. But it's the one I wanted to use. It more directly compares with my NOCO charger. This was the best data set. It starts off at a little bit higher voltage. In this case, the batteries weren't quite as much discharged. They were maybe 50% or so. And it's the same profile, basically. You can see the voltage come up, stabilize out about 13.44 or so, and hang in the mid 13.4 range. This anomaly in the middle of the chart, I was running long enough that I thought my generator was running low on fuel, and so I stopped it for a couple of minutes, gassed it up, started it back up again, and that caused the voltage drop and voltage rebound. And then this little one over here, I think I had a clip lead issue, but essentially, other than for that anomaly in the middle, which really doesn't affect the charging any, it's just that the voltage stopped, restarted, and when it restarted, it ended up at a higher level. I think I upset the charge profile a little bit by stopping in the middle, and so it started from a different point. But essentially, basically, I charged half the battery in 750 minutes or whatever. 600 minutes would be 10 hours, so that's what, 60, 11, that's about 12 hours plus a little bit. Here's your NOCO charger, or my NOCO charger. And the interesting thing for this one is that it starts in the same point as the previous one, about 13.15 or so. So it's a similar voltage level, similar state of charge. And you can watch that come up, you can watch the curve come up, and this one charges more at 13.51, 13.52. You don't think that's a lot of voltage difference, but it's a significant difference in charge current, and I'll show you that in just a minute. But it runs out here for a period of time, then ramps up to the top, and then goes into this sawtooth pattern. And that one kind of surprised me. I didn't understand the sawtooth pattern, so I had to do some digging in. But I'll address that for you in a minute. So, looks like a good charge curve. I mean, it comes up with a slope and then comes across here and heads up. So here are the two curves side by side. Now recognize that both of these charge curves started down here at about 13.15-ish. They were very similar charge levels, stated charge levels. I mean, one might have been a little higher than the other, but when you look at the difference in time duration, it's a lot, right? It's not like we were off 10% or something. So the red one is that ProMariner curve, and again, not picking on ProMariner, it's a flooded lead acid battery profile. And if I bought somebody else's charger with a flooded lead acid battery profile, it likely would look similar. It's it's trying to charge at a reasonable path, reasonable level, and come up here and finish about 14.6 or so. So then here you can see the NOCO, and to see them both get to a full charge in such a different time. So, I'm out here at 12 hours plus for the lead acid profile, and if I use the lithium profile, I'm all done in about 5 hours or less. That's a big difference. And why is that? Well, that little bit of voltage makes a big difference. So if I go back to my Pro-Mariner charge curve, my lead acid charge curve I should say. You can see it come up here, come across, and go through its profile. And then here's the charging current. Now the voltage was coming right off of my logging voltmeter, and the laptop was picking it up. It can't read the current, so I was picking the current off by looking at the monitor for the BMV-712, my battery monitor, and looking at its data. And it's a little hard because it's the screen on your phone. You know, I took the data from the phone, put it on a PowerPoint slide, and expanded it so that I could pick data points off of it. And that's what those little stars are. So you can see that it starts at about 8 or 9 amps and rapidly drops off as the charge current, or as the voltage comes up. And so then it settles out, and you spend most of your time charging at about 5 amps, maybe a little under as you get out here. And you can see the blip here in the middle where I stopped and restarted charging. And so it went back up to 10 amps for, you know, a very, very short period of time, and then came back down and was charging again at 5. And then as the voltage swings up, the current tapers off until you end up down near 0. So that's a lead acid type profile. Nothing wrong if you're charging a lead acid battery, which I had on this boat for years, but that one. Here's what the NOCO charger looks like. You know, the time scale in minutes is different. I expanded it. But it ramps up very rapidly to, see, the current is over here on the right hand scale. So as the voltage starts to come up, the current goes up to 10 amps. Actually it's about 10.2 or 10.15 very quickly. And it stays there rock solid all the way across. It doesn't deviate. It holds 10 amps for, you know, 4.5 hours or so. And then when it gets to this break point, you know, it sees the voltage starting to come up on the battery, and it's getting above 13.6, and so then as that voltage takes off, the current ramps off accordingly, and then you get into this sawtooth profile, and you end up with a sawtooth current profile that goes with the voltage profile. And again, I'm going to explain a little more in a second where that came from, because I was really scratching my head. It was like, why is it doing that? And how long is it going to do that? Because when I've been using my lead acid charger, I let it get to 14.6, I let it hold for a half an hour or so, and then I cut it so it has some time to equalize, and then I stopped charging it. So this one kind of bothered me. So this is an expansion of that curve that you see down in the lower left. You can see I just took that section of the curve and expanded it. This is what you get. Now, the sawtooth is actually, I'll say, prettier and nicer than that in real terms. The way I set up my data logger, it only takes, just to keep from having way too much data, it takes a data point every 60 seconds. And so, if one of the peaks in this curve, if you get the peak in the curve and it happens at 30 seconds and then it starts to go back down again, you won't read the peak on the meter because in 30 seconds later it's already starting down and then it's picking up that point. I lose some resolution, but for the purposes of what we're doing, it keeps you from working off of 10,000 data points. Basically I'm just giving it once every minute. Now, what you're seeing it do though is it's going on up, and you can see, I'll go over here, you can see that it gets all the way to 14.6 volts as a peak, and then it relaxes to 14.4, and then it goes up and charges again. And this one, as I said, this one kind of had me concerned because I didn't understand what it was. So I went back to NOCO's technical support and asked and said, what is this? Why is this? How long does this happen? The technical support folks gave me this chart first, and it said, oh, well, when the charger gets to the end, it goes up here to the top, and it it shuts off and it slows down and it goes to a resting voltage of 12.8 or so, and then it comes back up again. And it goes through this kind of a sawtooth, and this is sort of normal. This is the maintenance profile. And I said, okay, but that's not what I have. I'm not going down to 12.8, I'm going to 14.4, so can you tell me what's happening here? And I went back and forth with somebody at technical support by email. We were, sending data. I sent him, pictures of my data back and said, can you explain, what's going on? And so he said, well, I'll go to the engineering department. I said, wonderful, I'd like to know what they have to say, because I was still within 30 days of having the charger. And if it was defective, I would, send it back and return it in the return window. So I really wanted to make sure it was right and that I wasn't hurting my batteries. NOCO's explanation, this is verbatim, I took it straight out of my email. It says at the end of each charge cycle, the battery reaches full charge, which is 14.6. Then the charger goes to lithium cell balance mode for 4 hours. So it's going to do that sawtooth for 4 hours. Now, it's not charging for 4 hours. It goes to 14.6, and then it turns off, and it relaxes, and then it punches it again, it goes to 14.6, so you're going back and forth. And it says it'll have the breathing green light. On the front of the NOCO charger, they have status lights, and when you get to a full charge, you get a green light. And when it's pulsing, it's either in this mode or in a maintenance mode. And eventually, it'll stop charging and then, go to a solid green light. So this made a whole lot more sense. And then these batteries, my Battleborn, and let me restate this slightly. NOCO wants you to use this on batteries that have a battery manager. They don't want you to use it on 12-volt batteries that don't have some internal, what they call BMS, battery management system. So when it gets this full, the battery management system will say, hey, I'm at 14.6, and it'll stop charging. When it's in this in-between range, if the batteries still need to be balanced, the BMS can pull more current in, can open up and draw some more current. So that made me feel a whole lot better. This was an interesting finding, and I was glad that the engineers confirmed that my charger was working correctly. So then, again, you go back to this one where once the 4 hours is over, it will shut off, and it will stay there until this goes all the way down to 12.8, and then it's going to come back in and go back up to 14.6 again. And it's not clear to me, but it may be that if you did that you'd go into that 4-hour equalization mode and then go back into this profile. I searched their website, and they don't show the profiles anywhere. I had to go through technical support, and the gentleman that I was going back and forth with was identified in his signature as a technical support supervisor. So he understood what was supposed to be going on, and as I say, he went back to the engineering department and got me some better information. If I go to my BMV-712, and these are the screens I get off my cell phone, I'd really love to get these screens on my laptop, but it's interesting, the monitor, it'll Bluetooth to a phone, it'll Bluetooth to Android, I think it'll Bluetooth to an iPhone, but it won't Bluetooth to a laptop. And I've tried a bunch of different ways. It's just the way their software works right now is they don't have the protocol to go to Windows. So anyway, these are blow-ups of my screens that I get off my cell phone. And you can see here's the voltage. You come up from the bottom, it comes up, runs across here and makes its transition. What's on this screen and what's interesting, and just a point, is, well, it's two things. The first one is that I have this battery monitor. The battery monitor is on one of the two batteries in the pair. It measures voltage of both, but it measures current, charge and discharge on one battery, and state of charge on that battery. Because of that, it draws a little bit of current off that battery, and so the state of charge over time, the two batteries will drift apart just a little, a couple of amp hours. It's not a lot, but they will vary a little. So what you're seeing here is the one on the left is the battery that I'm monitoring, and you can see it going through its full charge, and we looked at the current and we know what that is. What we don't see is on the other battery, which is this right hand side plot, this is both batteries together. So you have two charge banks, one for each battery, and you're measuring across both charge banks. And just what I'm interested in here is, maybe you think it's excessive trivia, but just for an understanding, is you get about halfway up and you can see right here that you've got something going into sawtooth. And I don't have the current to prove it, but what this looks like is you see both batteries following a similar pattern, but when you get up here to this intermediate point, the other battery has apparently gotten to full charge first because it doesn't have the monitor drawing a little more current off of it, and it has gone into equalization sawtooth mode about maybe 20 minutes or a half an hour before the other battery does. So the two just charged at a slightly different rate, and ultimately they're both going, and the sawtooth gets a little bit ugly because their voltage is sawtoothing at different times. Not a problem. It's just interesting. You look at the data and you say, well, why does it look like that? I'm sorry, that's my engineer background, right? You look at it and say, why is that? Well, near as I can tell, that's why, and I've seen indications other times charging that the two batteries charge at slightly different rates. And so, this one's called starter battery. That's just what the monitor has, a spare voltage input, and that's what they call it, and I can't edit it and make it something else. They intended you to use that for your starter battery, but it works just fine to monitor the pack. It's just that's where you'll monitor one battery and it'll be 14.4, and then you'll go to the other one and it'll be 28.8, which is two 14.4s in series. And these two batteries, once they're fully charged, are usually within a few hundredths of a volt of each other. So in any case, I've now got my NOCO charger installed. I think it's working great. Since I took this data, I've run it down and charged it a second time. And it's really nice that, instead of waiting 10 or 12 hours to get this charged up, I get the whole thing charged up in, 5.5. And I like that because, as I've said before, and you've seen, I've had the generator. I'm doing this away from the house with a generator sitting on the dock, potentially disturbing the neighbors. And so I can plug this in, I can go put 50 amp hours in 5 hours, pretty nice, and shut the generator off, put it in the car, go home, and quiet things down, and not have to go back and forth and monitor things and make sure the generator ran out of gas, whatever. So, because now I could charge, if I went down, I generally run into about 50% state of charge, but now, if I go down to 70%, I'm going to charge it in 7 hours, right? Or down to 30%, 70% used. The mental math in this is really easy because I have a 100 amp hour set. So 100 amp hours is 100%. So 1 amp hour is 1%. So it makes it easier. If I had 50 amp hour batteries or 75 amp hour batteries, I'd have to do some other conversions. But the idea that I've got 100 amp hours, if I pull it down to 50%, I've taken out 50 amp hours. It makes it kind of convenient, I'll just say. But highly recommend this charger. It works really nice. Got it in there. The ability to run lead acid profile on one battery and lithium profile on the next battery over and set the three of them independently is even nicer. So that's all for now.